Okay, this should be the finale, the final video, probably part 7. And basically, what I want to talk about here is when we're dealing with misfire and we do our diagnosis, we determine something from relative compression or from our vacuum waveform or from our tailpipe cranking waveform, one of our waveforms, that we do have an engine mechanical problem, and there's a possibility that we may have leakage past an intake or an exhaust valve. So what I'm going to do here is that I'm going to use two transducers in unison together. I have the WPS in the cylinder number 1. Now, cylinder 1 will be our test hole, and if we have a cylinder under suspicion, if we've determined what cylinder has low compression, and we want to determine whether it's, what part of the upper end is doing it, intake or exhaust valve, we go into that cylinder and we're going to bring that cylinder to top dead center. We're going to use the transducer and slowly crank the engine to get the harmonic balancer real close to TDC, to where in theory a good cylinder will have both valves closed. There are variables I realize. Just say the cylinder that you had under suspicion didn't have compression, and you'd have to obviously look at your firing order. Let's say, for instance, that cylinder 1 failed egregiously its relative compression test, and I wanted to go into to do this sort of leak down style test. I would go to the cylinder before that in the firing order being 1, 3, 4, 2. I would go to 2 and bring 2 to top dead center on its compression stroke, and then I'd swing the harmonic balancer another 180 degrees, being a 4-cylinder. Obviously, if it was a 6-cylinder, you'd be 120. An 8-cylinder, you'd be 90, and if it's a 10-cylinder, and if it's keep going up and down the line, just so it's basically a lot about math. So anyway, I have the transducer in cylinder 1 to determine TDC. I will move that transducer, and I would change the setting to a range 3. I'm on range 1 now. I'm using the Uscope, as you can see right here. I will then move that transducer to the intake manifold. Then I will put another compression hose into cylinder 1, and I will blow air into that. I'll pull out flutter air from a hand pump into the cylinder to see if that cylinder in fact is leaking at top dead center, to determine if there could be compromise of the intake or exhaust valves. I do have a transducer in the tailpipe also. I'm just setting this up. So I will be switching leads. Obviously, with a 1-channel scope, we'll have to do this. We'll have to make it. We got a long BNC lead from the tailpipe up to my junction point, so I can go either way. My setup there, my BNC to banana adaptation, and there's the scope. So basically, I'm going to start the video, and I'm going to start by let's get cylinder 1 to top dead center on the compression ratio. Obviously, this engine does not have a problem. If we did have a problematic engine, we would be looking for blow bypass, an intake, or an exhaust valve. I will create a situation to see. I will actually swing the crankshaft to where the exhaust valve will open to see what a leaking exhaust valve will look like. I'm doing this with just a hand pump. It's from a cooling system pressure tester. Cooling system pressure tester that builds about 5 or 6 psi will flutter the air pressure. If you're in a shop and you have 90 psi, or take your air nozzle with a conical tip, I wouldn't be afraid to do that too. Just get it into a compressor and flutter the air, because these delta sensors, they respond to change in pressure. You'll get a more, I think you'll stimulate the sensor more to get a true reading on the delta sensor. The absolute sensor, the WPS, would pick it up either way, but nonetheless, you want to pulse that air into that cylinder, and it should it get by the intake or an exhaust valve, you'll see it on the respective transducer that we have hooked up. Also, you can use this on the crankcase. You just put your transducer on the oil cap, like you've seen in the earlier part of this segment, or you can put it on the radiator and see if there's a pressure wave in the cooling system, possibly a compromised head gasket. Anyway, I will tell you what I'm doing. I'm going to slowly roll the crank clockwise. I got a wrench on the harmonic balancer. The Honda has real good accessibility with that little trap door in the right side, lower by the right front tire. Anyway, I will turn that. You will see it slow. I'm going to turn it real slow, and I'm looking for a slow pressure rise. And then I will hit the plateau, and then I know that piston's at top dead center on the compression stroke. And I look at the harmonic balancer to verify that. So here we go. I'm going to go make a slow clockwise roll with the crank. Yeah, I still got to probably go through some other cylinders compression. It will start. Okay, still going clockwise. Keep an eye on the scope. And now I'm starting to climb. Okay, I'm definitely coming up. I want to I don't want to overshoot it, so I'm still cranking clockwise. Going up, another turn. Up. Okay, I know I'm probably there because I started to go down. You see that? I'm gonna look at the balancer. It's at least good enough for the leak down test. If I was splitting hairs with a timing chain, I'd probably have to get it more exact. But nonetheless, on a good cylinder, both valves should be closed. It is at the top of the compression stroke. I'll look at the harmonic balancer, and my spots, my notches on the harmonic balancer are really close to the notch on the timing cover on this Honda. So anyway, so now I'm at TDC, and I'm going to make a flip. I'm going to take the Pico WPS out of the cylinder. I'm going to actually redo the range. I'm actually going to shut it off, let it test itself, let it calibrate itself, go through the 1, 2, 3. Now I'll go down to 3. And I'm actually going to go to the zoom because I want a real sensitive setting, because I'm actually physically creating this pressure by turning the crankshaft. So I'm pumping air manually into the cylinder. So I'm going to switch my compression hoses. I'm going to go to a normal old school compression hose I got on Amazon, simple, with an air nozzle on it, and I'll put the pump on the hose. Basically, I'm screwing in there. I'm going to put my air pump on the end of my compression hose, and I will put my So I'll take one. Now I have a transducer on the intake and on the exhaust. Just give me a second. I'll get it on there. Okay, I got the transducer on the intake and the exhaust. I'm on range 3, real sensitive. I got the delta sensor in the tailpipe. Now I'm at top dead center on cylinder 1. In a good world, both valves should be closed. I'm going to pump in, and I'm not seeing anything, which is understandable because I got a good cylinder. Okay, in a bad cylinder, I may see something on the, if the intake valve were leaking, I'd see it on my intake lead. Let me switch my transducer to the rear one. I'm just going to flip my leads around so we're on the tailpipe now, so I can look at exhaust valve to see if that's compromised. Let me get my okay. I will pump into the cylinder and nothing. So we got a good cylinder. Now I'm going to as I said, I'm going to simulate what a leak would look like. So I'm going to go to about, I'll swing 165 to 170 degrees clockwise to where the exhaust valve, in theory, would be open. So I am on the crank, I'm swinging. You may see some action on the scope, and I'll talk about that. There's a reason for that. Here. Okay, let's see what happens now. You saw some action. That was most likely the effect of other cylinders in their strokes, in particular any other cylinder that was on its exhaust stroke with an open exhaust valve, you know what I mean. That transducer in the tailpipe will feel all the cylinders when the crank is rotating. But nonetheless, okay, there we go. Now I got an open exhaust valve. If I had a leaking exhaust valve, this is what it would look like at TDC compression. And I'm going to continue over to the intake stroke to see what that would look like, and then we're going to end this video. So this is a quick way to check out. I have to switch my transducer leads to look at the intake, because I am dealing with a one-channel scope. It's a very good scope, so I just switch my leads over. I'll take my leads off going to the rear, off the BNC lead going to the rear. So I'm strictly looking at intake now. Okay. Looking at intake. I will pump up. Maybe we're in overlap. I see nothing. Okay, so before we had pressure blowing past an open exhaust valve, so we're sort of I guess we'd say we were on the exhaust stroke. As this piston ascends to top and center, it will enter the intake stroke, and we'll see. We probably start to see a waveform. Anyway, I'm going a little more clockwise. Probably I feel TDC. Now I can see something. I'm going to say I'm starting to go down in the intake, so I should see something. No, I don't. Okay, a little bit more. Okay, now on the intake, let's see if I see anything. Okay, now we got intake action. I am blowing right past the open intake valve. Now, if we had a valve issue at TDC compression, obviously this is what it would look like. So I just kind of simulated what a compromised valve would look like with the one-channel Uscope and two transducers, one of them a delta sensor in the tailpipe, a piezo sensor, and the WPS is an absolute, but at range 3, it is super, super sensitive. It's going to pick up anything. I could breathe on the thing, and it'll take it off the screen. So anyway, this is just a quick way to, if we ever, basically the gist of all these videos, this is kind of it on the Uscope misfire, is if we checked everything, we ruled out our fuel, our spark, and our compression testing led us to consider we may have a valve issue, because we saw something in relative compression, we saw something on the vacuum pulls, and we saw something on in-cylinder cranking or running, and this is just a way to look at where our intake or exhaust valves may be leaking. Anyway, this is Mark, a technical technician from Diag Nation, signing off. Hope you enjoyed the video. We all learned something. Thanks a lot.